In this lesson, we're going to talk about variables, expressions, and properties, and some of these things will be a review of topics we have already discussed, but it's always good to come back to these as we will be using them throughout the year. To start off with, a variable is a symbol, usually it's a letter, and it represents a number. You guys are pretty familiar with what a variable is. Oftentimes we use the letter X as a variable or Y, but it could be any letter of the alphabet that represents a number. And the branch of mathematics that involves expressions with variables is called algebra, and that is the course that you're in this year. The expression 2 times n is called an algebraic expression because it has a variable and a number, and it has at least one operation. Multiplication is the operation. So we call that an algebraic expression. Oftentimes we will want to evaluate or find the value of an algebraic expression. To do that, for instance, if we're using the algebraic expression 2 times n, and we wanted to evaluate that for, say, n equals 4, we would substitute or replace the variable with a value or a number to give us a numerical expression. A numerical expression is different than an algebraic expression because it only has numbers and operations. It has no variables. So then we can find the value of the expression, and we would use our order of operations, which we will review in the next slide. Our order of operations, as we've talked about already, there's a mnemonic device called PEMDAS, and it stands for Please Excuse My Dear Aunt Sally. And as you know, the P stands for parentheses, the E stands for exponents. Multiplication and division are given the same priority, and the priority goes whichever occurs first from left to right. Similarly, addition and subtraction are whatever occurs on the leftmost side first, from left to right. So, algebra uses special ways of showing multiplication. A couple of those are maybe the X symbol that you see, but we don't like to use that very often because that could be confused with the variable X. Notice the difference in the font. Whenever you see an italicized font, that's a variable, whereas this one, where it's not in italics, is a multiplication sign. So usually we'll try to avoid using that so we don't confuse it with the variable X. And instead we'll use things like 2 and then this solid dot n, or 2 parentheses n, or just 2n. All three of these mean 2 times n. We also will be working with expressions like 7 to the second power or x to the third power. These are called powers or exponents, and they represent multiplication that's repeated. For example, if I have 7 to the second power, what that means is 7 squared, or 7 times 7. It does not mean 7 times 2. That's a common mistake that students often make. It's the power 2 tells you how many times 7 is multiplied by itself. So over here, when we have a variable to a power, that means that variable is multiplied by itself 3 times. So it's x times x times x. Now 2 and 3 as exponents have their own name. When we have the exponent 2, it's called squared. When we have the exponent 3, it's called cubed. All of the other exponents will just be called to whatever power that is. So if you had to the 4th power, it would be x to the 4th power. It doesn't have a specific name like cubed or squared. If we want to evaluate algebraic expressions, what we're going to do is we're going to substitute in whatever number for the letter. So in this example, we have 6 times the quantity x minus y in parentheses squared. So they're telling us x is equal to 7 and y is equal to 4. So what we're going to do to evaluate is we're going to go ahead and plug in the number 7 every time you see an x, and we're going to go ahead and plug in the number 4 every time we see the letter y in our expression. And we'll just replace those letters with the numbers. So let's go ahead and see what we get when we do that. So 6 times, instead of x, we're going to put 7. Instead of y, we're going to put 4. So the first thing I'd like you to do is just write that out. Then we can start working with our order of operations. We start within parentheses first. So since the 7 and the 4 are inside the parentheses, that subtraction gets done first. So 7 minus 4 is 3. Then we need to use the exponent. The exponent gets the next highest priority. So 3 to the second power, or 3 squared, is 9. So we have 6 times 9, which is 54. Here's another example. They want us to substitute g equals 5. So everywhere we see the letter G, we are going to change the letter G to the number 5. Now remember, when we have a number and a letter together, that means multiplication, okay? So in the first part of this expression, we have G squared, so that means 5 squared. Then we have minus 2G, which is minus 2 times 5, minus 4. So 5 squared, remember that's 5 times itself, 2 times, so 5 times 5 is 25. 2 times 5 is 10, and then minus 4. So we have 25 minus 10 minus 4. Now here's where you need to remember how to add and subtract numbers with different signs. 25 minus 10 gives you 15, and 15 minus 4 is 11. When we have a fraction bar, that's a kind of a grouping symbol. A fraction bar is the same as having parentheses around the numerator or the denominator, okay? So when we want to evaluate algebraic fractions, in this example we have m equals 9 and n equals 5. So wherever we see the letter m, that will become a 9, and the letter n will become a 5. So let's see what we get here. In the numerator we get 4 plus 6 times 9. In the denominator we get 2 times 5 minus 8. So make sure that you're taking the time to write that step out so you won't make mistakes. You'll make a lot less mistakes if you go ahead and write out your work. So our grouping symbols, 6 times 9 is 54, and 54 plus 4 is 58. So our numerator is 58. In the denominator, 2 times 5 is 10, and 10 minus 8 is 2. So we get 58 over 2, which is the same as 29. The properties here, we have already talked about all of these: commutative, associative, distributive, and identity. The commutative property deals with the order in which numbers are added or multiplied. So it doesn't matter what order we add or multiply numbers, we get the same answer. The associative property deals with how we group them. Notice we can group the second two together or the first two together, and it doesn't make any difference for addition or multiplication. We will still get the same answer. Now that is not the case when we deal with subtraction or division. We'll talk about that a little bit more in the next slide. The distributive property tells us that if we have a number outside of a parenthesis, everything in the parentheses gets multiplied by that number. So a times b plus c, first we multiply a times b, and then we multiply a times c. And whatever sign this is in the middle is the sign that it stays. So in this example we have AB minus AC. Here are some examples with numbers. And then our identity just means if we add 0 to a number, we get the number back. If we multiply a number by 1, we get the number back. So this one says to name the property shown by this statement. Well, if we take a look, what's happening? Are we changing the order? We have 2, 5, and then n, 2, 5, and then n. So we didn't change the order here, but we did change the grouping. On the left side we grouped the last two together, but on the right side we grouped the first two together. So if we go back to the last slide, when we deal with ordering, or not ordering, but changing the grouping of things, that is our associative property. Counterexamples are a way of telling us, if we can come up with a counterexample, we can say that something is false. Okay? So here's an example. If we have the statement, division of whole numbers is commutative. If we can come up with one counterexample, we can say that that's false. And we don't have, that's how we would prove that it's false. So the commutative property says the order doesn't matter. So let's take a look. What if we took 15 divided by 3? Is that the same as 3 divided by 15 if we just switch the order? Well, on the left-hand side, 15 divided by 3 is 5, but 3 divided by 15 is 1 over 5. Clearly those are not equal, so therefore we can say division of whole numbers is definitely not commutative. That's a false conjecture. And that's it for this lesson. We'll see you next time.